See here, yesterday we were discussing about, we started electromagnetic induction. So what is electromagnetic induction? Suppose there is a wire and there is no current in the wire and we are taking a magnet. Okay, we are moving the magnet, like there is a relative motion between the wire and the magnet. When there is a changing magnetic field, current is induced in the wire. When there is a changing magnetic field, current is induced in the wire. This phenomena is known as electromagnetic induction. This phenomena was first found by Henry Joseph and Michael Faraday. Actually, Michael Faraday has found this concept. Okay, so because of that only we are enjoying the electricity today. Whether it is that is AC current, I mean DC current was discovered by Thomas Alva Edison, who invented the electric bulb. Okay, so till that time we have only direct current only. So that's what I told in, if you visit some palaces like in India, like Mysore Palace, you still see the electrical lines. It was built some in 1800 AD, but still you see the wiring. That wiring was not for AC current, it was for direct current. Okay, those bulbs and everything work on DC, not AC. AC bulb will not work in DC, and DC bulb will not work in AC. It's like that. Okay, so that is why even the lamps which are fitted in the car and motorbikes and all, they are different. Entirely different. They are different. Okay, the phenomena, they work on a different phenomena. Now, coming to the first the Faraday's law of electromagnetic induction. He says that when there is a relative motion between a magnet and a wire, then there is a induced EMF developed. That is given by E is equal to minus d phi b by dt. This is a formula. What is the phi b? Phi b is known as this phi b is what? Quick. We have to finish off this lesson today. After that, I can go for alternating currents. What is phi b here? What do you mean by phi b?
Sir, magnetic field.
Magnetic. Anyone? What is phi b?
Movement or field. Any one of those.
Phi is the symbol for what? Oh my God, you are going to write the board exam, man.
That is.
Huh? What is phi b here? What is phi b? Hello, Dhruti, how are you?
The permittivity in the B region or something.
What is it? But this phi b means what? I'm asking phi. Phi is the symbol for what? We have phi E and phi B, right?
Magnetic field.
Huh?
Magnetic field.
Magnetic flux. It is magnetic flux. Is that clear? Phi b means magnetic flux. Phi E means what? Electric flux. E means electric field. Capital E means electric field. Capital B means magnetic field. Is that clear? Please learn. Okay.
Yes,
start keeping practicing. Okay. What Faraday told? Faraday says that, once again, see here. According to Faraday, he says that if there is a wire, there is no current in the wire, and you are changing the magnetic field. When you're changing the magnetic field, current is induced in this wire. Current is induced in this wire. Now people ask how current will be induced. Because this magnetic field, this magnetic field. Now keep your mobile away, otherwise I will value your efforts.
Sorry.
Understood now? Now, okay, I'll directly write your dad now after that. Now, see here, there is a wire here, and this is the magnetic field. When there is a changing magnetic field, current is induced in this wire. So people asked how the current is induced in this wire. So what happens is, when the magnetic field is moving towards or away from the wire, the electrons, the free electrons, this is a conductor. The free electrons in the conductor, they experience a force. They experience a magnetic force. Because of that force, they start moving in one direction. Is that clear? This is known as induced EMF or induced current. Got it? Is it clear?
Yes.
Okay, now according to Michael Faraday, what he said is, when there is a relative motion between the wire and the magnetic field, current is induced. Okay, so that formula is given by what? The induced EMF is given by E is equal to epsilon. E is equal to minus d phi b by dt. What is phi b? Phi b is said to be magnetic flux. What is magnetic flux formula? What is magnetic flux formula?
E dot ds.
Yeah, very good. B dot d. Yeah, B dot ds or B dot A. Okay, or B dot. We can also write B dot S also. Both are same. A is also area, S is surface area, both same. So B into A cos theta. Is that clear? Are you understanding?
Yes, sir.
And magnetic flux is measured in what? Magnetic field is measured in what? First of all, magnetic field is
Weber.
measured in
Weber.
Weber. Very good.
Weber or Tesla?
No. Magnetic field, I said. Magnetic field.
Oh, okay, so
Magnetic field is measured in Tesla. Only Tesla. Magnetic field B is measured in what? Tesla or Gauss. Magnetic field is measured in Tesla or Gauss, but magnetic flux is measured in what? Weber or Tesla meter square. Understood? Is that
Yes,
clear?
sir.
So Weber or Tesla meter square. Is it clear, all of you? Is this clear, all of you? See,
Yes,
these four
sir.
lessons, again, I'm telling you, like the
Yes.
first lesson, second lesson, and third lesson, static electricity, capacity, that is first three lessons carry 18 marks, and these four lessons also carry 18 marks. Forget about that magnetism and matter. It's very small lesson. Hardly 2 or 3 marks can be asked from that lesson, not more than that. But you have to only consider fourth, sixth, and seventh lesson. This is sixth lesson. Electromagnetic induction is a sixth lesson. These again carry 18 marks. Okay, so don't ignore these lessons. And again, if you ask me, sir, which out of these four lessons which carries more marks, then I will say fourth lesson will carry more marks. Is that clear? So please focus on these lessons. I'm explaining in modules. I'm not going with the lessons. Okay. Is it clear, all of you?
Yes, sir.
Yes, sir.
So at least when you are attending the classes, be attentive and try to understand what is happening in the classroom. Okay. Now, so once we are done with the practical examination, I will be completely focusing. I will be taking 2 hours class. If you are available, I will take 2 hours class. I will try to solve past paper with you people. Or not, if you are not possible with 2 hours, at least I will take 1.5 hour class and try to solve at least half of the past paper, one paper. Like I will take one sample paper and discuss that paper in 2 classes. Okay, 1.5 hour and 1.5 hour, like that. Is that clear? Is it clear, all of you?
Yes, sir.
I'll be
Yes, sir.
solving it literally with you. It's not like I'm going to leave the paper with you. I'll be doing each and every paper. I'll be sharing the screen. Okay, we have Shivakshi has given me a projector also. So I will use that to project it on, and I can explain better. Okay. So now here we have E is equal to what? Minus d phi by dt. That is equal to what? Here we have d phi b by dt. This is what? Rate of change of magnetic flux. So whenever there is a change in magnetic flux, current is induced. Is that clear? Whenever there is a changing magnetic field, current is induced. So why negative sign? Because changing magnetic field and induced EMF both are in opposite direction. Changing magnetic flux and the induced EMF in the wire both are in the opposite direction. Is that clear?
Yes, sir.
Okay, so either you write, suppose for mathematics people, it will be easy to understand d by dt. What is d by dt? Rate of change. So for bio people, we write delta phi b by delta t. Is it clear? Is that clear?
Yes, sir.
Yes, sir.
This is the first statement what I discussed yesterday. Okay, yesterday only Arham was there and I think ma'am left in between. Okay. Okay, so now
Which man?
why are you interested?
No, I'm just asking, ma'am. means
New one will come now.
Okay.
there's a small confusion.
You have so many doubts. Okay. Now E is equal to what? Minus delta phi by delta t. Okay, that is the first one. The second one is about the Lenz law. Lenz law, I told the story of the dog and the noble man. Okay. Ashas. Okay. Yeah, Ashas.
Sorry, sir, I forgot that story.
That story you forgot, right? Okay. Now, so I'll just explain here because I want to, I will not erase completely. Okay, I'll just write, I'll leave this part on it because I want to explain. E is equal to BLV. I'll write here. Now here there is a wire. There is no current in the wire. Okay, this is a wire. Okay, and this is a magnet. Okay, this is a north pole and south pole. Okay, so when the magnet is made to move towards or away, current is induced in this one. Is it not? Current is induced. First there was no current because of the changing magnetic field.
Yes, sir.
So current got induced. When current got induced around it, what happens? There is a magnetic field, right? There is a magnetic field. This magnetic field and this magnetic field, they repel. Is it not? This magnetic field and this magnetic field, they repel. This phenomena, this was explained. So they repel each other. So this was explained by Lenz. According to Lenz, what he says the polarity of the induced EMF is such that it tends to produce a current which opposes the change in magnetic flux that produced it. Example, suppose this is a dog and this is a nobleman. Okay, so the dog was about to die. Then the nobleman he brought to his home, give food, milk, everything. On a sunny day, this fellow, the dog, has bitten the owner and ran away. It means it betrayed. Okay, so suppose there was no current in the wire. So suppose there was no current in the wire, because of the changing magnetic field, current got induced. And when the current got induced around it, there is a magnetic field. That magnetic field and this magnetic field, they repel each other. Got it? Is that clear?
Yes,
Yeah,
sir.
sir.
Yeah. So this is known as what? This is known as the Lenz law statement. Okay. Please do write the Lenz law as it is. Lenz law is an important concept. A statement is asking. State Lenz law. Do not write the story in the statement. Write the statement as it is, what is given in the notes or in the textbook. It says that, once again I repeat, the polarity of the induced EMF is such that it tends to produce a current which opposes the change in magnetic flux that produced it. Clear? Write the statement as it is for both Faraday's law and Lenz law. Now I'm going to see what happens when the magnet is, suppose this is a magnet, north pole and south pole of a magnet. Clear? Now this is a coil here, the circular coil. So what happens when the magnet is made to move towards the coil? What happens? Current will flow in anti-clockwise direction. ACW. Current will flow in anti-clockwise direction, and a north pole is formed here. And a north pole is formed. According to Lenz law, he says that I'm explaining the Lenz law and conservation of energy at the same time. Now, when the north pole is made to move towards the coil, there is no current in the coil, the circular coil, no current in the coil. But when the magnet is made to move towards the coil, current is induced in current starts flowing in the anti-clockwise direction, and a north pole is formed. Now people asked, how come north pole form? It can be south pole also. Then he explained. Okay, then he explained like this. Suppose think that if a south pole is formed, a current is flowing in the clockwise direction. Example. Okay. Now what happens when before the magnet moves, it gets attracted, is it not? Before the magnet moves, it gets the north pole of the magnet gets, you know that unlike poles attract and like poles repel, is it not?
Yes, sir.
Yeah. So unlike poles attract, north and north will repel, south and south will repel, north and south will attract each other. Now, when the north is moving towards the south, it should get attracted. So before you apply force or you use your energy, it gets attracted and passes through the coil. So it is violating the law of conservation of energy. What is law of conservation of energy? Energy is neither created nor destroyed.
Not destroyed.
But can be
Transferred from one.
transferred from or converted from one form to another form. So that is how it has violated the law of conservation of energy. So this is wrong. So what is our contradiction? The contradiction went wrong. So whatever he said before, the north pole, that means current only flows in anti-clockwise direction. And what happens? Is that clear? When a north pole of the bar magnet is moving towards a stationary wire or a coil, a north pole is formed and the induced current flows in anti-clockwise direction. Is it clear, all of you?
Yes, sir.
Yeah. Now, the second part of this conservation of energy. Suppose this question can be 99%. This type of question can be asked in assertion reasoning questions. Assertion reasoning questions. Okay. Such type of question it is. Okay. There is no explanation for this, only evaluation. Now, suppose there is one more coil. Here it is what? Okay. So here, one second. So now, suppose here the magnet is made to move away from the coil. So what will happen? A south pole is formed. Okay, a south pole is formed and the current flows in clockwise direction. South pole is formed and current flows in clockwise direction. Is that clear? Current flows in clockwise direction. When the magnet is made to move away from the north pole of the magnet is made to move away from the coil, a south pole is formed and current flows in clockwise direction. Then people asked, how are you sure that it is a south pole? It can be north pole also. Then again, he explained in this way. See, what is the explanation? See here. Now, suppose think that it a north pole is formed. Example, a north pole is formed and current is flowing in this direction. Are you understanding the contradiction?
Yes, sir.
All of you?
Yes, sir.
Yeah, I'm explaining this. Actually, explained yesterday in the classroom. Okay, but again, see here. Suppose if a north pole is formed, north and north will attract or repel?
Repel.
No, repel.
North and north will repel, right? So north and north will repel. Is that clear? So north and north will repel. So then what happens? The they both will repel, but without moving the magnet is being repelled. Before I was not even moving towards or away from that. Just I kept it stationary, but it started pushing the magnet. So again, is it not violating the law of conservation of energy?
Yes, sir.
Yeah, it is violating, right? It is again violating the law of conservation of energy. So therefore, whatever he told, okay. So whatever he told, when the north pole of the bar magnet is moving away from the magnet, then a south pole is formed and induced current flows in clockwise direction. Is that clear? Is it
Yes,
clear all of
sir.
you? Yeah. This is the second one. Third one. Okay. Third one is what? Emotional EMF. Okay. I'm going to explain this one. Is it clear with all of you? Yes. Can I go ahead now? So I have explained what is electromagnetic induction. I have
Yes, sir.
explained you what is Faraday's law of electromagnetic induction and what is the formula. And for Lenz's law, when do we get north pole? When do we get south pole? This I also have explained now. Okay. The statement you have to learn, and law of conservation of energy. Law of conservation of energy also you have to learn. Okay, this is only a theoretical part, not there is no derivation in it. Okay, now next one. So next is motional EMF. There are two derivations in this. This is qualitative study. After this I will teach you the normal quantitative study also. That is a small one only, not big one. So now what happened is in the second part. Okay, this is the second part of the thing. So we have the formula E is equal to what? BLV. Now suppose this is a cross. Cross means what? Is the magnetic field going into the board or out of the board? Is the magnetic field going into the board? The cross current. Into the board. Yeah. The magnetic field is going into the board. Okay, cross. Dot means
Out.
it is coming out of the board. Yeah, very good. So we have dot and cross. Dot, whenever I see dot, current is coming out. Okay. Whenever you see cross, current is going in. Now let me again go back to fourth lesson. When the current is coming out of the board, is it clockwise or anti-clockwise? The magnetic field. Current is going in. I told you, no, sir. What is that? Right hand grip rule or right hand thumb rule. So if the thumb indicates the direction of the current, curled finger shows the direction of the
Magnetic field.
magnetic field. If thumb indicates the direction of the current, curled finger shows the direction of the magnetic field. Now suppose if this is the thumb, how is the magnetic field? Clockwise or anti-clockwise?
Anti-clockwise.
Anti-clockwise. So anti-clockwise. Please do write ACW. Okay. Counterclockwise. In some book it is CCW. Okay. Better write anti-clockwise so it will be easy for you to remember. Now suppose if it is cross, means current is going in. Is it clockwise or anti-clockwise? Is it clockwise or anti-clockwise?
Clockwise.
Clockwise. Very good.
Clockwise.
So it is clockwise. Understood now? So this is what we have now. So now, but here this is not current. It is a magnetic field. Magnetic field is going into the paper. Then into the paper. There is only magnetic field, not changing magnetic field. One normal magnetic field. There is a metallic frame. Now this is a movable frame. Okay, this is moving with velocity v towards the coil. So what will happen? X is the distance and L is the length and X is the distance. Now what happens? When it is made to move, it is cutting the magnetic lines of forces. How much is the angle?
90.
See, they are kept at 90 degrees. But
Yes, sir.
when you see the current, when it is moving, what happens? It is cutting the magnetic lines of forces. It is
Yes,
cutting
sir.
the magnetic lines of forces. When it is cutting the magnetic lines of forces, magnetic current is induced in the wire. Current is induced in the wire. Understood now? Okay. So what will happen?
Yes, sir.
Now here, I is equal to what? E by R. I is equal to V by R or E by R. R is the resistance in this wire. E is the EMF. What is EMF? Induced EMF. I'm not speaking about a normal EMF. It is a induced EMF. Whenever you solve problems or whenever you write for electromagnetic induction, write induced current, induced EMF. Is that clear? Induced current and induced EMF. Okay. Now I is equal to E by R. I is the induced current. E is the induced EMF. R is the internal resistance of the wire or resistance of the wire. So I have E is equal to what? Induced EMF is E is equal to BLV. B is the magnetic field, L is the length, and V is the velocity with which it is moving. This came from the first part. I'll explain that also. Now I is equal to what? BLV. So I'm writing here BLV divided by R. Now I also have formula. When a conductor carrying current, when a current carrying conductor is placed in magnetic field, how much is the force experienced? When a wire, current carrying conductor, is placed in the magnetic field, what is the force it experiences? F is equal to what? F is equal to BIL sin theta. Is that clear?
Yeah.
This came from the 4th lesson. Are you understanding?
Yes, sir.
Yes, sir.
Whenever you place a current carrying conductor in the magnetic field, the force experienced by the wire, okay, is given by what? F is equal to BIL or BIL sin theta. Okay, now F is equal to I is what? In the place of I, substitute this value. You will get B square L square B by R. Is that clear? Is that clear, all of you?
Yes, sir.
Okay, now come to power. What is power formula? Power, there are various formulas of power. Work done by time. In mechanics, there are two formulas for in mechanics. What is that? Work done by time and force into velocity. These are the two formulas for power. So in mechanics, so I'm just substituting F value and B value. We got this answer. Finish. Is it clear?
Yes, sir.
Yes,
No,
sir.
but power, we have three formulas. What are they? This is the mechanics formula. And this is the current electricity formula. Is it not?
So,
This is the formula from mechanics. And this is the formula from?
Electrostatics.
Yeah, current electricity, right? So we have three
Yeah.
formulas. We'll try to match whether the power, whatever we got from mechanics, is it the same as in the current electricity? We want to test it. So I'm taking I square R. Why I square R? Because I have I with me. That's the reason I have taken. Otherwise, I don't have V or E, I don't have. That's the reason. Now I'm substituting the formula. I got this one. So is it matching or not? Both of them. Are they matching? Are they same? This and this? This one and this one. Are they same?
Yes, sir.
Yes? Yes, they are same. Okay.
yes, sir.
Okay. So this and this is same. So therefore the power, that means the power calculated using mechanics method and the power calculated by electrical method, both are same. Is that clear? That is what he tried to prove. And next we have, this is the formula which came from Faraday's law of electromagnetic induction. And this is the formula we got, I is equal from here. E is equal to IR. From here I got. But what is I? Current is rate of change of charges. Okay, rate of flow of charges. So delta Q by delta T. What I'm doing now, I'm equating this to this one. Then delta T will go away. Did you understand now? I equated this value with this value. When I equated 1 and 2, this delta T will go away. Now cross multiply that delta phi B by R. That is the answer. Is that clear? Is
Yes,
that clear,
sir.
all of you? Okay. So what is that? Change in charge is equal to what? Change in flux by the resistance. So these are the three formulas. Is that clear, all of you?
Yes, sir.
Okay, please copy this quickly. Then we'll go to the first part also I will discuss now. The first part of the derivation also. The same one. Okay, just I'm giving 2 minutes. Just write it, copy.